Okay, so in this video we're going to use the conversion of IEEE 754 single precision binary float to decimal. Okay, so this is very, very complicated. So I'll go as slow as I can. I'm going to need to use a calculator for this one because, like I say, it gets quite complicated. You need to follow the process. Okay, so first point with this is single precision binary floats are 32 bits. Double precision is 64 bits, so we would expect a question to have 32 bits. I'm not sure how many that has, but I haven't counted them all, but you get the gist of it. If we've got a few short, it would have some zeros on the end normally. Okay, so we need to break these up into 3 separate chunks. The first one, like before, gives us our sign, so it'd be 1 for minus, 0 for plus, and then the next 8, 1, 2, 3, 4, 5, 6, 7, 8. That next 8 is going to give us our exponent, and then our mantissa is going to come from the rest of this here. Okay, so there should be 23 bits there if you're going to do it by the textbook. Okay, so we can bear this in mind that we're going to get an answer that's going to be a negative number here. Okay, this section here, if I convert that to binary, I should get 128 plus 2 plus 1, which gives us 131. I need to subtract 127. This is following on from the last video, which gives us 4. Okay, so 4 is our exponent, and for now we can park that. I'll just write exponent here so we can remember. So exponent is 4. Okay, so this is the complicated bit now. So these digits here, well, binary digits, by the rule we are going to do 1, because it's a 1, times 2 to the power of minus 1. Okay, so it's all about the place. If it was a 0, it'd be 0 times 2 to the power of minus 1. And the next one is 1 times 2 to the power of minus 2. And the next one is 0 times 2 to the power of minus 3. And then this one here is 1 times 2 to the power of minus 4. Okay, I can ignore the rest of it. And in fact, I can ignore this 0 here because it's going to give us an answer of 0. So, but you just need to remember the placement. So I'm going to add these together. So this is where I'm going to need a calculator. So let's just bring one up. Okay, so it's quite not easy on a Windows calculator. Hopefully you've got your own calculator. But if we go 1 times 2 to the power, let's put it in brackets, minus 1, plus 1 times 2 to the power minus 2, plus, I'll skip that one, it's going to be 0, so I'll go on to the 1 times 2 to the minus 4, power of minus 4, so plus 1 times 2 to the power of minus 4 equals. Okay, so that 0.8125, get that right, 0.8125, that is our mantissa. Okay, so from this now, to get our answer, it's always going to be 1, add your mantissa, so 0.8125. So let's just call it 1.8125 times 2 to the power of your exponent, which is 4. 2 to the power of 4. Okay, so let's calculate that. So 1.8125 times 2 to the power of 4 equals 29. So 29 is our answer. Don't forget, we've got our symbol. So that is our full answer, minus 29. So quite a long process, quite difficult. Take your time with these, break it up into 3 chunks. Make sure you're following the rules in this bit here. This is where it normally goes wrong. Okay, so remember, every time you move to the right, you're going up by powers of minus ones. Okay, on to the next video we go.